Hi there, my name is José Barbosa, and we're here to talk about SCADA, piscada. So hi again. In this session, we're going to be talking about the RTUs, the Pi RTU, which is an RTU based on Raspberry Pi. These systems are modular. So a Pi RTU is a solution that has one processor board and has a set of expansion boards that will perform different functions. These modular expansion boards may vary depending on the hardware manufacturer. In this case, the image shows us a sequent manufacturer, but you can have the same situation with a different manufacturer. For example, with the solution from Strato. Here you see the models they call ional units, and these are not modular. They are built in little boxes, which each one has a CPU and a set of modular boards inside, but within a closed enclosure. The software design for the Pi RTU is supposed to be the same for every different configuration of I/O boards and even of different manufacturers that we get. So we want to, with that, to increase the stability of the solution and also to have an easier support, because there's only one code to look at in the Pi RTU itself. We're talking about pirtu5 because this was designed for the Raspberry Pi 5, but we have tested it on the Raspberry Pi 4 successfully, and there's no reason not to use a less expensive or more cost-effective solution like the RTU Pi 4. When we talked about in another video about the architecture of the software, we've seen what we see here, this diagram that shows the full architecture of the piscada, the master station. I'm bringing it up here again to show that the RTU has a lot of similarities to this. Very shortly, as we said before, this is based on Linux. On top of it, we have a MySQL database. We have libraries in Python. We have a Mosquito broker and a MQTT clients to talk to the other units, to the RTUs that we're going to talk about. And then you have the here on the right, the user interface part, either with a local monitor or with a full Node-RED implementation. The important thing for the RTUs here is that there is a communication between the master station and the RTUs for the configuration part and for alarm acknowledge done through APIs. So when we look at the Pi RTU solution, the Pi 5 has a very similar architecture. You see the Linux, you see the SQL database, you see the Python, the MQTT client is there. The Mosquito server is not, because it will be only part of the main unit. And the user interface part is also similar, but you don't see the Node-RED. That's also an independent function. The APIs that exist in an RTU are possible acknowledge of local alarms, not mandatory, but can be implemented as well. You can have alarms on each independent RTU. And then the very important part of configuration that we're going to be talking about, the RTU config. So the main thing here is that we are using, as I said, the same software for all RTUs. So we need to know how does the same software for any configuration or manufacturer, how can it be defined for each particular architecture when we actually implement a project. So how does the piscada master tell the Pi RTUs as they wake up what they are and what they should do? As we've seen in the architecture, piscada responds to HTTP requests from the network, and whenever a Pi RTU, a Pi 0 RTU, or a Pico RTU, any of the three different architectures of RTUs that we have, when it's powered up, it is running a firmware that we said is the same, in this case for all, for the Pi RTU is one image, for the Pi 0 is a different image, and for the Pico, obviously also different image, but each one, when they wake up, they don't know yet what functions they're going to have, what board they have installed, and how it's going to work. The only information they actually know very well is their MAC address. It's well defined, and it sticks during their life to the unit. It is always there. So the beginning of the power-up sequence, the RTU is going to call piscada through an API and tell them, I have this MAC address currently, what am I going to do? And that's what is stored in a table inside the piscada database. That table is called a configuration table that we see here, and uses the MAC address as the fingerprint or the identification of the RTU itself. The server will then look up this MAC address and will tell the RTU its device type. This tells him what type of unit it is. It's a string, a code. It will also tell him what is the client ID for MQTT communication. That is a unique name that is going to identify that unit in the network. And then it tells him what is the server username and password for the MQTT communication. The RTU is going to tell piscada what is the current IP the RTU has. The IP of the RTUs can be dynamically allocated, and so it could change at any moment, which means that whenever there is a reconfiguration or a reboot, the IP that is assigned to that particular RTU is going to be communicated to piscada through this process, and it is stored there. Then there's a couple more items here, mainly related to the communication to the unit. The piscada needs to know whether it's talking to a pi unit, to a 0, or to a pico, so there's a family name in there. And then there's a keep alive signal that is going to indicate to the piscada master, but also to the users when they look at this information, whether the communication with this particular RTU is in good shape or not. So if the communication fails, the piscada is going to mark this information as a 0, as a fault in the keep alive, and then regularly it will try again that unit to see if it comes back to life, and it will adjust that variable there. We are now going to open a database editor as an administrator. So we look here at the database editor for this particular file called configuration, and we can see then that in this case we have 7 lines, which means we will have 7 RTUs configured in the network. Each one has its own device type, and each one obviously has its MAC address, and this is the address the units have communicated to the master to indicate who they are. The master then will tell them that they have a particular client ID. This has to be a unique name as well, and will tell them the server address, username, and password that the units will have, and the units will echo back the current IP address they have. And as I mentioned before, family tells the type of unit you're talking to, and the keep alive will tell us that in this case we have 2 units that are not cooperating, not communicating, the others are communicating, and this counter here allows us to do the following. The period of keep alive is a parameter in the database. You can define 10 seconds, 1 minute, whatever you need. And then if the unit fails, you don't keep requesting information from the unit all the time. So we will wait for 10 counts of that same period, and only at the end of that period we will try again and see if it is rebooted and if it is communicating correctly. So as long as it is communicating correctly, it will be queried periodically as defined in the database. Thank you for watching.